Hi everyone, this is an artwork that I made and I used geometry script and a material for that, and that's basically it. So I generated some fancy mesh using remesh so that I have this beautiful triangular shapes on the left, and then I used something I want to show you today. It's called CurveAtlas. So a CurveAtlas is a very efficient way of passing gradients, super smooth, uncompressed, interpolated gradients to a material. And here you can see that I transition between several gradients, probably just two, and based on polar coordinates, so around the circle. They transition between one and the second one. They are made using curves. So you basically draw some curves or make a gradient, and then they are internally stored by Unreal as textures. So they are extremely efficient to read. They are just textures and they can have few pixels. They don't have to be very wide because everything is using the GPU interpolated between them. So this is a technique that you may have used yourself, but if you don't know that curve atlases exist, it will be a tedious process of import and re-export and so on. So let me show you this. If you download the project files that you can find either in the pinned post on Patreon or on my Gumroad or via techart8.com/products, then you can go to the techart8 streams project, go to 2024-05 blob. Here are some assets and I will show them in a second. You may want to rename them because this is a kinda funny name in Polish, maybe not so funny to some. Basically a wordplay on curve. Okay, envelope. Envelope is a chaotic material because, as I said, it's an artwork. But you don't have to know everything in it, you just need to see the part with the gradient. So let me go to it. As you can see here, this node, what is it? It has my custom name, so you can't see the type. But basically, you right click and CurveAtlasRowParameter. So let's unpack these words. CurveAtlasRowParameter. Curve, because we are dealing with curves. Basically, gradients are color over an x-axis, right? So you can visualize that if I open a curve, that each color is actually some RGB strength at a given point. You can call the x-axis time, but basically it's just an x-axis. And y is the value. So the value goes from 0 to 1. In my case, the time goes from 0 to 1. And here is the result. So we will be sampling this gradient based on luminance. As you can see, as you know, values of pixels, so like the luminance of a pixel, can be also expressed between 0 and 1 as a single number. So you can use luminance as the x-axis of the curve. So the brighter our mask, the rightmost color will be chosen, right? So curve time here, curve time in that node is basically a moment on the x-axis. So it's not time, it doesn't have to be animated anyway. If you put some brightness here, some black and white mask, white will refer to the rightmost pixels, black will refer to the left edge, and everything in between will be in between. So that technique is called gradient mapping, and it's been used, I think, even in games by Valve, such as Left 4 Dead. So really long time in the industry. In the Super Nintendo and such, it was used for palettes. It was at the time indexing, it wasn't smooth as a gradient, but still, this has a long history. So we want to use it now, and as you can see what happens, I have a mask that goes left to right on a cylinder, or like so, and then it refers to a particular color Let me visualize you that time. Let's call it time. It may take a while. So that's our mask. You can see how white is in the center, black is on the edge. So white means the rightmost part of the gradient, so black again. Then should be some brown, and then on the left should be some violet. So if I stop previewing this and start previewing that, here we go, give it a second. Our gradient mapped on that mask. Now the cool thing about this whole atlas thing is if I modify that, if I change that black to pink and go back, here it is, instant, without any reimport. The texture is generated in the background and we don't care. Okay, stop previewing this node. So again, CurveAtlasRowParameter. Curve, we already know what it is. Atlas, because we can have multiple such curves in a single file. And that's amazing, I will show in a second. A row, because these gradients are stored as rows of the internal texture. Parameter, because we can choose in a material instance which one to sample. So let's add it. CurveAtlasRowParameter. Name is whatever. And then on the left, in the details panel, you select your atlas. In my case, it's this one. And then you can select one of the curves that's packed in that atlas. So how does it look like? I have only two curves in it. Two gradients. Oh no. It happens. Okay, again, sorry. Back to where we were. So such an atlas can contain multiple gradients. In my case, it has only two of them. I don't know if you can see that because they're very thin, but if you make such an atlas, you specify how many pixels horizontally you want. Let's reduce it for a while to 32. Oh, now it should be more readable. And then texture height is how many gradients you want to pack into that single atlas. So look at this, just 32 pixels wide. And then I can pack 32 gradients vertically. I add them here in the array. So I don't have many more right now, but you know, assume I can just add some of them, anything at that point, and they get added automatically. Look at this, it's just 32 by 32. It's so small, it weighs almost nothing. The resource size is 8 kilobytes, the smallest possible, and it's uncompressed. You also don't need the square resolution. That's the first thing that you should disable. So let me show you how to create this from scratch. And then I'll show you what to disable. So we are in a folder, we click add, and then we go to material. No, sorry, not to material. We go to miscellaneous, but it's outside of the screen. So just believe me that I'm doing here curve. And so I typed curve, I click curve. It asks me what kind of curve. What you want is curve LinearColor. It's the only one supported in materials. The other two are for blueprint. So this one is cool because it's universal between blueprint and material. So do see my curve. Here it is, color curve. And looks like that. So let's add some color. You click on the empty space between the two existing colors. Bottom is opacity, top is actual color. So you click on the top twice, double click on the new thing that showed up, the square, and you select some beautiful color. Can be like that. Then you double click again, do it some turquoise color like this. Then I can do some dark purple blue. And here we go. And we have a gradient. As you can see, they're kind of chunky. You don't observe it on the top, but you can kind of see it. Like on this point, it's blocky. It doesn't look good. You want smooth curves. So drag and select all the points. On the topmost toolbar, select cubic interpolation and just click it. And now they're smooth. One bad thing is that they go beyond 1. So, and they clip below 0. Our color should by default be between those two. So I'm gonna erase this, but as you can see, there is snapping. It's irritating. So on the toolbar again, disable snapping, but you can keep time snapping. So time snapping is the horizontal thing. So now if you disable vertical snapping, only keep the horizontal one, you can nicely move it up. But it snaps again, so that's not an option for us. In that case, in that curve, I will disable it because I didn't put it on a frame. Okay, so to move them up, I select all of them. And here, choose which axis movement is locked to. Y only. Because you don't want to desynchronize the colors between themselves. You want them to be on the same point of time. Otherwise, you lose the square. So you don't want to do that. You want to keep them together. So in the toolbar, I click Y only. And now I can safely move the channels individually. The color changes, sure, but not so much. And I want to have it between 0 and 1. So I move it up just enough. It's just above 0 and just below 1, like so. And I'm good. Okay, the gradient looks similar, but it's now smoother. I also recommend you to play with it later and to play with the tangents. You don't want that bad tangent like this. You want to smoothen out the curve like so. I mean, it's an artistic decision at this point, but smooth curves usually also look better as color. Like this. You want to maybe bring this up, bring this down, because this basically are your RGB intensities, right, of each channel. So it makes sense that they follow some logical shape, not just be, you know, bouncing wildly. Like this gradient looks similar, but it's just better in a sense. Okay, I save it. I have one curve. Let's duplicate it. I go back to content browser, I Control D, and my curve 2. And I open this, and let's change these colors a bit. Again, having this vertical movement, I'm gonna raise the green, like so, raise the red, like so, and reduce the blue. And raise the red. And now I have different colors, of course, it's all very cool. Like this, maybe, or maybe like that. Perfect. And without snapping, thank you. And now I have some greenish gradient. Let's move this down. Okay, perfect. Maybe to add some variety, I'm gonna bring this up. And here down. Perfect. Save it. Back to content browser. I have two curves. So add miscellaneous curve atlas. Curve atlas. Sorry, it's below the screen. And CA my curve atlas. I open this. And by default, it has 256 by 256 resolution, which is first way too much because we have linear interpolation on the GPU. We don't need that precision most of the time, unless we have some noise to display. And why is it square? Why is it square? Like disable square resolution. Texture height is just the number of curves, so 2. Texture width, I recommend you starting with 32 or 64 and check if this is enough for you. So I have 64, as you can see, it's plenty of values. I add my gradient curves in the gradient curves section, and it will be my curve and my curve 2. Here they are, packed into an atlas. Now, to make a material that responds to that, add material m my curve test, like so. I use substrate, so yeah. But basically we're gonna just make a material, don't worry. blend model opaque, shading model. I have to create a substrate thing, unlit BSDF. Normally in Unreal, what you would like to do is to click on empty and on the left, change the shading model to unlit or whatever to emulate what I do. But substrate is substrate. It's a new material system coming to Unreal in the future. I already enabled it in the project. Okay, substrate unlit guarantees that this material supports emissive color and nothing else. And now, to read the curve, right click, CurveAtlasRowParameter, my chosen curve, curve time, these coordinates will be basically UVs. So right click, texture coordinate, split it. So component mask R meaning U, so X. I know it makes a lot of sense. Basically the U coordinate of the UVs can be extracted by using R of the RGBA. And it goes here. So UVs, they look like this. These are the UV coordinates. Then the masked red component. Oh, what have I clicked? Sorry. The masked red component looks like so. And then the curve. So it asks me what atlas and what curve. Atlas will be my curve atlas, and the curve, let's say the blue one for a moment. So that's how our grayscale input looks like. And that's how the result looks like. So as you can see, the black in the mask refers to the left part of the gradient, the white refers to the right part of the gradient. Grayscale in between will give you the color on the curve in between. So that's a very simple technique. You can supply anything you want. If you add noise, let's say noise, which looks like this, and let's make scale 0.01, like this. If you supply this noise to this curve and make it not -1 to 1, but set output minimum to 0, so 0 to 1, that's important for the curve. So if you make the noise 0 to 1 and supply it to the curve will look like so. So yes, these are our colors. If I'm gonna change this curve to the second curve, the green one, it changes. Woohoo! So it's super easy. Now you can have material that does various effects, like, you know, fire, plasma, whatever you want, in many varieties. And just in a material instance, you can swap the gradient that's used. Let me prove this point. Let me create a material instance. So I go back to browser. I add material instance, my curve test. I open this material instance, and as the parent, I select my curve test, so the shader. Here we go. And now I have a parameter. It's my chosen curve, and I can select between curves from that atlas. One click. So that's basically it. And that's how powerful it is, because, okay, I supply a static mask. But what if I take this and in the world position, I supplied texture coordinate and append vector time multiplied by scalar parameter speed. And let's attach it like so. And let's make this time times speed the third coordinate. So now I have 2D coordinates plus some magical third coordinate. Well, it's certainly magical when you attach something like this to noise to the world position. Because what happens then? I should increase the scale back to 1. Or maybe even to 2 or 3. And as you can see, there is our noise. Now it's based on UVs, but this third coordinate will be animated noise. So let's do speed 0.1 and bam, it moves. It's so simple. So basically 2D coordinates plus a third coordinate based on time gives you animated noise like this. So now if I go back to this material instance and enable real time, you can observe how nicely it animates. Like so. So yes, here we are. We have our curve atlas. And now back to the blob. You can probably imagine how now I sample between two different curves from the same atlas, and I blend between them based on some radial polar value. So that's so simple. And the magic here that's happening is harder to explain. It's basically my abuse of the vertex interpolator. So I make these choices of value happen on vertices rather than per pixel. And this mesh is quite low poly in that area. So the beautiful magic happens. So observe this nice calming scene for a while. And basically, thanks for watching. Go to techart8.com to either visit the Patreon or visit the products page if you want to download the project files.